Hello everyone, welcome to the 6th lesson of the CrowPanel Pico Display tutorial. In this lesson, I will teach you how to use Squareline Studio to create a UI and display it on CrowPanel. The process is divided into creating the UI, exporting the UI, and invoking the UI. But for the convenience of beginners, I will start from installing Squareline. Next, watch my operations. Open the browser on your computer. Search for Squareline Studio, find its official website, and open it. After opening, click Downloads here, and it will redirect you to the download page. The latest version is currently 1.4.2. Then you just need to click the corresponding download link according to your operating system. After downloading, open this compressed file and run the installer. After clicking Install, it will install automatically. After the installation is complete, click Finish. Next on the desktop, you will see the icon of Squareline Studio. Now I will start demonstrating how to create a UI project and design UI in Squareline Studio. Open Squareline Studio. All these projects you see here are created by me. Click on Example and you can see these examples provided by Squareline Studio. But you need to pay attention to whether the resolution of the board matches the example used. You can find the resolution of the board you purchased on the Elecrow website, and this information is available in the product title. Based on the resolution, only this one matches the resolution of my board, but it's okay. We can create our own UI in the menu above. Click on Create, then click on Arduino. There's only one option here, which is for the TFTFPI library. But in reality, regardless of what library you're using, as long as you're using the Arduino IDE, you can use this option. Because when we export, we only need the UI file. Nothing else is required, so choosing this option won't have any restrictions. Next, on the right side here, you can customize the name of your project. I'll just write something random here. Then there's the path where the project will be stored, which is also customizable. But make sure to remember the location. The most convenient way is to create a folder for each project, which will make it easier to manage. Then there's the screen resolution. Just fill it in according to the resolution of the board you're using. The rotation angle can be left as default. Then the color depth option is crucial. Make sure to select 16-bit. Our boards all use RGB 565 encoding, which is a 16-bit color depth. Don't make the wrong choice. Lastly, there's the version of ElvGL. In the previous lesson, I already emphasized installing ElvGL version 8.3.11. So just select the corresponding one here, then click on Create, and you'll see the generated initial interface. In the lower left corner, you can see all the available widgets. If you find it inconvenient, you can also adjust the size of each toolbar in the interface. These widgets are frequently used. When you want to add one to the interface, just click on it. It will automatically appear in the center of the interface with the widget selected. You can modify various information about the widget in the Properties panel on the right, including the most common style settings. We can adjust its color. Next, there's the outline. I'll change it to black and set the width to 5, making it more noticeable. In addition to these, we can also modify the text color of the button as well as the font size of the text. However, currently this button doesn't have anywhere to add text. So we need to add some click here to add a label. But we just set the button's text color to yellow. Why is this text still black? It's because we haven't set this label as a child of the button in the hierarchy panel on the left. Drag the label and drop it onto the side of the button. At this point, a small triangle will appear on the left side of the button, indicating that the label has become a child of the button. But currently, the label is outside the button's bounds, so it's not visible. Only when you move it within the button's bounds will it be visible. And you'll find that the text on the label has turned yellow. Next, we can modify the text content here. Also, when I drag the button, the label will move along with the button. Now, if I add another label and don't make it a child widget of the button, it won't be affected by the button's properties. I'll change its content to Hello Elecrow. Currently, we only have one screen, but the goal of this lesson is to create two screens and switch between them by pressing a button. So I need to add another screen now in the Widgets panel. Click here to add a new screen. Then you'll see the newly added screen 2 appears on the right side of screen 1. And screen 2 is selected by default. You can use the green status bar above to determine whether screen 1 or screen 2 is currently selected. Next, I'll add the same widgets to screen 2, a button adjusted to a similar position as the button on screen 1, and then add a label. I'll set this label as a child widget of the button and change the button's label content to button B. Finally, I'll add another label and change its content to Hello Squareline Studio. That's it. We're done. At this point, you can click the triangle button here to simulate the UI we designed. But you'll notice that when I click the button, screen 2 doesn't switch to screen 1. This is because we haven't added an event to this button. Click the triangle button again to exit the simulation. Then select button A on screen 1, and let's add an event to it in the inspector panel on the right. Scroll down to the bottom and click Add Event. Here we can choose the way the button triggers the event, which can be pressed, click, or release. I choose Release, which means the event will be triggered when I release the button. Next, select the action after the event is triggered. I need it to switch screens, so I choose Change Screen, then click Add. After that, complete the information for this event. I need it to change to screen 2. Additionally, to ensure there are no memory leaks during switching, I recommend adding an action to delete screen 1 when switching to screen 2. Similarly, on screen 2, add a similar event to button B. But to distinguish the effect, I'll change button B's trigger method to press while the action remains the same. Switch to the other screen and delete the original screen to avoid memory leaks. After adding events to the two buttons, let's click the Simulate button again to see the effect. When I press button A or button B, it automatically switches between screen 1 and screen 2, which is the effect I want. Okay, the UI is designed. Next, we need to export the UI as a code file. Click File, then open Project Settings. We need to set the project path here when we created the project earlier. We already created a folder for it. We'll use the path of this folder as the project path, then choose the export path for the UI file. Usually I would create a folder named UI under the project folder to store the exported UI files. And I recommend you do the same. Next, enter lvgl.h. In the lvgl, include path. Then ensure that the flat export option is enabled. Click Apply Changes. Finally, click Export and select Export UI Files. The UI file will be exported to the path you just set. Next, let's start by locating the code needed for this lesson within the course files. If you're unsure where to download the course files, you can find the download link in the video description below this video. Then navigate to the directory where you exported your UI files just now. Here they are, the UI files you just exported. We need to import these files into your Arduino project. The import process is straightforward. Simply move the UI files into the directory of your Arduino project. Open the directory of your Arduino project and move all the UI files over. That's it. Now let's open the Arduino project. You'll notice that the code for this lesson is almost identical to the previous one. However, since we're not using LVGL's demo in this lesson, we don't need to include those two header files. Instead, we've included a new header file named ui.h. Why is that? This header file is one of the UI files you just exported. Let's scroll down to find out more. Here we've commented out the LVGL demo and added a function called UIUnnet, which is declared in UI8. Additionally, you can find the prototype of the UI init function in the UI file. So by including UI8, we're able to call UI init to load the UI designed in Squareline Studio. This means that the rest of the code remains unchanged from the previous lesson. Think of LVGL's initialization as a frame and the UI init function, along with the LVDemo widgets function, as different paintings. The frame stays the same. We just swap out the paintings or their contents. Let's take a look inside the UI init function to see what it does. In the UI init function, it initializes screen 1 first, followed by screen 2, and finally loads the content for screen 1. Let's dive into what happens during screen 1's initialization by switching to the UI screen file. Here you can see that the function first creates screen 1, then button 1, and subsequently label 1 and label 2. In between these creations, there's the initialization of styles for the created widgets. All of this has been designed within Squareline Studio, and you can open Squareline Studio to see the exact widgets used for screen 1. They should have the same names. The process in UI screen C is similar, where it creates the widgets designed in Squareline Studio. Now that we've covered the design, import, and calling process of the UI, let's upload the code to the board to see the results. First, connect the board to your computer using a USB-C cable. Once connected, click on Tools, select Raspberry Pi PPICO from the board's menu, and then click on Tools again to choose the corresponding serial port for your board from the port menu. Finally, click on Upload to send the code to the board. After the code upload is complete, the board will automatically reset and you'll see the screen on the board match exactly what I just designed in Squareline Studio. Moreover, when I press button and release it, the screen switches to screen 2, whereas pressing button B immediately switches back to screen 1. This aligns perfectly with the event trigger conditions I set up. Since this UI has a resolution of 320x240, it can also be used on a 4.3-inch display. In the course materials, find the code for the 4.3-inch display in Lesson 6 and open it. You might wonder, the display and touch driver libraries for a 4.3-inch board are different. How can it work? Great question. As I mentioned earlier, the display and touch drivers along with the LVGL initialization are like a frame that we've already prepared. We just need to swap out the picture inside that frame. I've opened the code for both the 2.4-inch and 4.3-inch boards, and you can clearly see that the modifications in both are identical compared to the previous lesson. In fact, I detailed the steps for initializing LVGL in both codes in Lesson 5, and they're the same. So when you want to use a UI file exported by someone else, all you need to do is make sure the resolution is the same. Then copy the UI file to your Arduino project directory. Next, let's upload the code to the board and see if it runs properly on the 4.3-inch screen. First, connect the board to your computer using a USB-C cable, then switch to the code for the 4.3-inch board. Click on Tools and find Elecrow CrowPanel RP2040 DVI under the board section. Next, click on Tools again and select the corresponding serial port for your board under Port. Finally, click Upload to upload the code. Once the code is uploaded, the board will automatically reset, and you should see the same effect as on the 2.4-inch board. Now you should understand why, in subsequent lessons, I won't repeat this explanation and will directly use the 4.3-inch board for demonstrations. That's all for this lesson. If you find this helpful, please don't forget to subscribe to my channel. Thanks for watching. See you next time.